Now we continue the section 14.4, cylindrical coordinate and spherical coordinate. In equation here, 그러니까 아까 example ask us to change. This is errata. The cylindrical coordinate when the cylindrical coordinate is 4, 3 over pi, and g is equal to minus 3, then what is the rectangular coordinate of that point? So x can be found as 2, and y can be found as 4 times sine pi over 3, which is 2 square root 3, and g is minus 3. So the rectangular coordinate of the point whose cylindrical coordinate is 4 pi over 3 and minus 3 is 2 root 3 and minus 3. And find the cylindrical coordinate of the point whose rectangular coordinate is minus square root 2 and root 2 and 1 is r is square root of x square plus y square, which is square root of minus 2 square plus square root 2 is equal to 2. And tangent theta is y over x, so root 2 over minus root 2, which is minus 1, which says theta is equal to minus pi over 4, and g is equal to 1. So the answer is 2 minus pi over 4, and 1 is the answer. So those are the change of the coordinate from cylindrical to cylindrical to rectangular, and from rectangular to the cylindrical. And describe the surface whose equation in the cylindrical coordinate is g is equal to 2r. And then g square can be written as 4r square, which is the 4 times x square plus y square. And we recognize this equation is a circular cone whose axis is the g-axis, like this. And example 3, find an example in cylindrical coordinates for the ellipsoid y 5x square plus 5y square plus g square is equal to 1. In this case, since r square is equal to x square plus y square, so g square can be written as 1 minus 5r square. So the equation is g square is equal to 1 minus 5r square. This is the cylindrical coordinate equation of the ellipsoid, this one. And next, spherical coordinate. Spherical coordinate. The spherical coordinate rho, theta, pi of a point can be obtained from its Cartesian coordinate p, x, y, g by the formula of this, and theta like this, and pi like this. From triangles OPQ and OPP prime in figure 6, we have g is equal to rho cosine pi and r is equal to rho sine pi. Okay, so conversely, the Cartesian coordinate may be derived from the spherical coordinate of this by x is equal to rho sine pi cosine theta, and y is like this, then g is equal to rho cosine pi. So which satisfies rho square is equal to x square plus y square plus g square. Okay, and this, this shows changes from Cartesian coordinate to cylindrical coordinate, and then next to the spherical coordinate. So the point x, y, g can be represented as a length of the length is rho, and the angle from x-axis are theta, and angle from g-axis are pi. So go to theta degree this much, and pi degree from g-axis, and the length is rho, that represent the same point in the rectangular coordinate in spherical coordinate. Okay. Okay, here's the example. Write the point of this is given in spherical coordinate to rectangular coordinate. Suppose we have a point in spherical coordinates like this, then change it to the rectangular coordinates. So x is like this, y is like this, z is like this. So just plug in rho pi theta here to have what? Rho theta pi. So to have square root 6 and square root 6 and g is equal to 2. So this is a rectangular coordinate of the same point. And the point, this is in the rectangular coordinate. Find the spherical coordinate for this point. Then rho can be found in this way. Cosine phi can be found as this because arc cosine was pi was arc cosine g over rho. So we can, since we all knows and rho and pi and theta, so we can just plug in it in here to have pi as a pi over 3 and cosine theta is 0, so theta is pi over 2. So this gives us the rho and theta and pi as the spherical coordinate. Okay, so now we continue. So all you have to know on these are the replacement of this as a rho is like this, and arc theta is arc cosine g over rho, and pi is arc tangent y over x. Okay. That's what you're supposed to know to have this translation. And the last page of this lecture is find the rectangular coordinate of the point of this one in spherical coordinate. So I gave a code like this. So you just this command changes the spherical coordinate to the rectangular coordinate. And so here the answers can be obtained in this way. And here, here you identify the surface whose equation is given by g is equal to r square. In this case, I had a 3D plot of this r square from r 0 to 2 and theta from 0 to 2 pi. So if we see it, then this gives us the 3D plot of those domains, which looks like this cone. Okay, so I think that's the end of this section, 14.4. And here's the examples and solutions and the code that you can change it. For example, this changes the spherical coordinate to cylindrical and spherical coordinate. So these are the things that you can utilize. I think that's it. Okay, we will continue the section 14.5 in the next